Okay, good morning. Welcome to the ELIXIR CZ Friday Coffee. There is a series of the lectures or short seminars about the tools and services we are providing for our users. This time is interesting because I suppose that all of you are using Protein Data Bank and visualization, the PDB. So we will hear David Sehnal from Masaryk University Brno, who will describe us the journey they actually performed during the evolution of the Mol Star, which is a web-based visualization and analysis of large-scale molecule data tool. So David, please, the floor is yours.
Hi, thank you for the introduction. So as you have seen for the past few minutes, if you've been here, I've been showing this screenshot or what we call graphical abstract for our latest publication, which we have submitted for Mostar. And if you look at it, we can actually start from visualization of single atoms and then go all the way through like protein families, experimental data, dynamics, viruses, nuclear pore complexes to cell level models. And when thinking what to talk about, I actually kind of realized that this didn't happen overnight, and I thought it might be interesting to kind of show what it took to get to developing software like this. So basically, to start, where we are now is this viewer is available directly in the protein data bank. So if you go to say RCSB and click on 3D view of a structure, it loads this Mol Star viewer pretty much immediately. Same thing if you go to the protein data bank and click on 3D visualization, you also get Mol Star in a slightly different version. And Mol Star actually wasn't the original viewer that was there before. Like long before I started, I kind of realized that we need a good 3D viewer. I was working on this server during my PhD called web chemistry. And as part of web chemistry, I developed the application called pattern query, which allows you to define expressions which then can be executed in the whole protein data bank, and you find the motifs. But if you go to the page and we see the visualization, it's quite boring. This was actually written in 2014, 2015. And back then there was pretty much just JMol or JSMol, and it took like even minutes to load it up because there were like hundreds of modules and it was super slow. And there was just this super basic tool which I found out to do some basic balls and sticks model to at least display it here. So as time moved on, I was adding more and more applications to web chemistry. And one of them was called Atomic Charge Calculator, which was about computing charges on small molecules and even protein fragments. And here, the requirements for the visualization were somewhat more, the requirements were higher. So what I did is I wrote a basic 3D viewer, which I started to call LightMol. And this is the first public occurrence of LightMol, where you were able to select some basic things. The UI wasn't very interesting, but there was some, it started to kind of look nicer. And I think this was in 2015 or 16, well, one of these years. And around this time, actually just a week after I wrote the first prototype of this viewer, I happened to go to visit Protein Data Bank in Europe, in Cambridge, and I showed this to them, and they said, "Well, basically, this is exactly what we need." And back then, they were developing ligand pages, where this is the modern display for it, where basically we're able to look at the ligand and its surroundings, and perhaps like the experimental data, which is the blue and green surface around here. And back then, the first iteration of this was like before the light mole before and MolStar now, it always, even though it showed this small portion of the molecule, it actually went ahead and downloaded the whole structure. So back then we kind of realized we can take this pattern query language for describing the molecular motifs within it and create a server that executes it on demand for each structure separately. So these requirements then evolved in something which we called LightMole Suite, which kind of consisted of several applications, which was LightMole coordinate server for developing of the for delivering 3D molecular data via like streaming, density server, which was for the experimental data, like the X-ray densities. Like here, this is okay. Oops, it's embarrassing, but it's old and deprecated now. And develop the binary CIF format to kind of compress the data even more. This eventually resulted in a Nature Methods publication, where kind of this is like one of my favorite examples, cryo-EM structure of Zika virus, where like the original data is 1.6 gigabytes, and to create this visualization on the left, it only requires us to send 1 megabyte of data. So this was a great success where previously it would take up to minutes, even on slower connections, to display structures like this to pretty much like immediate display. Now, parallelly, so this is a development which was happening at the protein data bank, and around the same time that I was developing LightMole at RCSB. Alexander Rose was developing Mol Viewer, which I think many of you are also familiar with. And in 2017, we met at a conference in New Orleans, and we actually decided it might be interesting to collaborate. So kind of to test out the collaboration, we wrote together this little project called MolQL, which was supposed to be evolution of the data delivery server, like this declarative language for describing molecular selections. And what it allowed you, it was a cool little application, cool little prototype, where you were able to define selection expression in various languages. For example, you could even say like PyMol and say, give me solvent 2.5 angstroms around the polymer, and then you could execute the query in a browser here. And kind of using this project, we found out with Alex we could collaborate together. So we kind of come up with this roadmap for the MolStar project. This is we call it MolStar because kind of the first application that we work on was called MolQL, and then we were thinking about what other modules we need, and it was always Mol something, Mol model, Mol data, Mol plugin. So kind of like the programmer that I am, I thought we needed more problems, so I thought, okay, let's use a regular expression as a name for the library, and at the same time it sounded quite cool, and that's pretty much how MolStar came to be. We started working on this in 2017, and in 2018 we had like the first working version, And over time, it was integrated into RCSB and PDBe, as you see now. And currently we have submitted a publication to NAR. Hopefully we will get it published soon. And okay, so I've spent some time now talking about how MolStar came to be. So I think we can get to actually showing how it works. And for this, we have this wide range of interactive examples. So before I started about the Zika virus, which is still kind of here, and you see it loads pretty much immediately. And I can dynamically change the ISO value, which updates immediately. And it's not just static image, you can play around with it, and you can even animate it. Because, for example, the molecular assemblies, these are actually not stored atom by atom, but they are kind of created with symmetries. And this process illustrates how from the small asymmetric unit, the whole capsid, the assembly, is actually composed. So this is not just simple viruses. We can also show protein families. So this example illustrates superpositions of, well, this is currently 9 cytochromes, and this is colored by validation, and we can, by the coloring, we can see which structures have some measurement errors in them, at least according to protein data bank validation. As you can see, even though this is a relatively large number of structures, it still loads kind of almost immediately. And taking it up a notch, we can display much larger structures. For example, this is so-called nuclear pore complex, which consists from 235,000 unique residues, and as you can see, it still loads almost immediately. It's actually interesting application of the binary CIF format which we have developed. So if I go to source here and I do PDB def, I think I can change here. If I try to download it in CIF, you can see download. It takes several seconds just to download the structure before it's being created. This is using the old approaches kind of naively. And in the meantime, they adopted this binary CIF format even in the protein data bank dev for the integrated hybrid structures, and you have seen how more quickly it loaded before. But it's not just showing the big or small structures, it's even how we visualize the structures. I really like this demo because it highlights very nicely the difference lighting can make. Like before, most of the solutions, and even now, would show the structure with basic lighting, and that is an approach called ambient occlusion, which kind of adds shading to the structure, and we can see that how the structure looks like is much more interesting and much more visually appealing, and communicates much more than before. Again, standard versus illustrative or ambient occlusion rendering. So it gives depth to the visualization. We have also done a lot of work recently in the past few months on displaying animations or dynamics. So here we have molecular dynamics of, I think it was, yes, Villain. And as you can see, it again loads immediately and replays with quite solid frame rate per second. Another example of this would be, there is a bigger animation now, 500 snapshots. And this surface, this is computed on the fly in real time on the GPU, and we can seek anywhere we want at any time and just look at the entire simulation from different points of view. And now, of course, now we can actually step it up a notch. So recently, Alex created this visualization of a lipid layer, which is like, I think it's like 50 megabytes of data, just super smooth in a web browser, or even showing the entire capsid for HIV1. So previously we were displaying just this purple part in the section. Just this purple part here is 2.5 million atoms, and the structure around here is 30 million atoms, and we can display it immediately, just within a few seconds in a browser now. And moving forward, I think it will be possible within the next, let's say, 3 years. It will be possible for this to make interactive and zoomable directly in the protein data bank based on the data, which will become available through various services. Okay, so now you've actually seen me just click on interactive examples, which would usually be scripted. But what's actually happening here is that Molstar allows state saving of the current state of the visualization. So if I load a structure and let's say enable volume streaming for the experimental data and click on a residue, I can zoom in, create a view, and then I can go to this old floppy disk kind of saving thing, and I do one TQN and upload the structure. And now I can open this in a separate window. You can see the URL for the application has changed, but anybody with this URL who goes to it will now see the same view. Currently, this is like a prototype implementation for it, because we do not have a stable server where we store all the data that the user have saved. But over time, we plan to make this into a stable service for users to share kind of results for them. Like what will be possible is, if somebody knows an interesting view of a protein, they will be able to go directly to the protein data bank, create a view like this, add a few 3D labels and annotations, click save, and any new user that comes in will see a list of the annotations provided by the other users. So it will be kind of, well, Twitter for molecular states or something along these lines. And yeah, that's pretty much Molstar. And it's open source and at the GitHub. Anybody can integrate it. We actually have quite a few people using this now. And like pretty much the biggest negative thing of this is it's quite complicated currently if you want to do something more advanced in Molstar to integrate it. So we started working on documentation. There is a viewer documentation, and we even started to write source code documentation, which we plan to drastically improve during this year. So yeah, I guess that's pretty much it. Unless I have a few more minutes, I can show one more integration, and otherwise I can leave it to you.
Okay, David, thank you very much. It's a very impressive, and I think most of the users are actually acknowledging the speed of the viewing of the molecules. I'm looking for some question, and the first probably is I have my own. So if you look on the protein families, are you able to see also the sequence conservation in that families, and it's possible somehow to visualize it?
So currently we have in Mostar there is a basic sequence view at the top here, and you can color these things differently. But for the conservation, I think in protein data bank, I don't know from the top of my head, but if I do molecule details, no, it's not here. Yeah, they have these like they have these sequence viewers, so you can kind of visualize multiple sequences and then visually say which part are conserved and which are not. So it could definitely be integrated with like sequence view component. And because if you can see here, if I hover mouse over a part, it highlights in all the different parts. So yes, it could be embedded into view like this.
Thank you. There's another question. If you consider having a desktop version, because the saving option is great.
Consider what?
Having a desktop version. I
Oh,
think
desktop version. Yeah, sorry. Yeah, like yes, it could definitely be wrapped in like something like it's called Electron to wrap a web application in desktop version. And yeah, this is a good suggestion. Yes.
And another question is if you can export images or movies from the session.
Oh yeah, exactly. This is actually one of the cool features that we added recently, which I forgot to mention about. But what I can do is, so for example, here I can do like camera spin, and it starts spinning around, and I can click on export animation, and again click camera spin and do render, and in a couple of seconds I have a movie which I can embed in a presentation like in MP4 format. So here I just click save animation and it's saved, and yes, I can do, and here is a special screenshot UI. I can select a super high resolution for the screenshot and then copy or download it and use it like that.
Okay. Are you thinking about the Galaxy integration?
Well, not actively, but that is definitely something that would be super cool to have.
Okay.
To be able to have it in Galaxy or Jupyter notebooks. And I think so Mostar is a community project, right? So if somebody wants Galaxy integration, they could actually just join us. It's a collaboration. It's not just me and Alex. It's like official collaboration between Protein Data Bank in Europe and RCSB and SciTech and others. And we've had a few contributions already, and I hope that more and more people will join over time and kind of help the ecosystem grow.
That's amazing. I think more people will appreciate it, that integration. Another question. You show the results of the MD simulation. So what is the mechanism for including molecular dynamic simulation results? I think it's not automatic. Not all of the proteins which are stored in the protein data bank actually have the MD simulation results included, right?
Oh no, of course. Like this is the Mostar variable is used in PDBe, but it is not limited to PDBe. Like one other example I can show is for example this is alpha orbitals demo. So what it does, it takes results from like Gaussian or some other quantum chemistry software, and it just takes like the coefficients for the orbitals, and directly on the GPU it just computes how the orbitals look like, and I can kind of zoom through them and I can show electron density immediately. So Mostar is much more general than just showing results from PDB, and the simulations here, they actually came there is a source for where the data came in. So there is a Wheeling trajectory, which is a data set created by Stefan Duer, and we transformed it and used the Mol state saving to be able to present it to any user through the interactive examples.
Mm-hmm.
And there are
So when you have, let's say, standalone version and you have your own results from MD simulation, so is it possible to connect these two things?
Yes, exactly. You can pretty much use it to display almost anything. Like even this visualization of the HIV capsid, this is not from PDB either. From PDB is like the small proteins are from PDB, but the way to compose them, this actually comes from software called CellPack. And the CellPack just said, download this protein and copy it here, and here. So it's much more generic than just going to PDB and getting all the data from there.
Okay, I think the last question. No, it's not. So David, it was very impressive, and thank you very much for the great presentation. And we wish you luck in the implementation of the Mol Star. I suppose that people who are interested about it, they can contact you, right?
No, of course, just either directly or through the GitHub, like if you, from the Mol Star page, join development on GitHub, and we can just use like the issues or discussion here to kind of see where it could be moving forward. And yeah, we are definitely happy for people to join us with developing Mol Star.
Well,
And
still last question appeared. So thank you for the nice presentation. What is your computer setup? So it means CPU, graphics, or whatever. On my notebook with Sunday Bridge Core i7 Mol Star is not as smooth in animation as the presented, yet still impressive. I'm asking so we know which users could have problems in the integration. Okay,
so it also depends on which viewer. Like the animation of the animations here, they run best in Chrome, and this one is Firefox, and I have like very high-end PC. I have like the latest Ryzen and GeForce 3000 something, so that's why it is so smooth. But in general, like this is as smooth as you can get currently in a browser, even for the older ones. Yeah.
Okay. David, thank you again, and thank you to all of you to be present. And please don't forget the next Friday Coffee is just 1 week ahead. So have a nice day and see you next Friday. Bye.
Thank you.